Hi, Miss Venable here from Quarantine, bringing you a little kitchen chemistry. This is a chemical reaction between zinc metal, which looks like this. It's a solid silvery gray kind of metal, very hard. And hydrochloric acid, HCl, which looks like this. And this is a pretty concentrated, 6 molar is the concentration of this acid, so it's clear. And something pretty cool is going to happen. So for starters, I'm going to take my test tube and I'm just going to add the zinc to it. And we always put in our reactant before we add our acid. You always add the acid to the reactant. So let's put in this acid. I'll put about 5 squirts in there. And what do you see? And what do you hear? Anytime we're making observations, we're looking for signs that a chemical reaction is actually taking place. So what do you see, what do you hear, and what do you feel? Of course, you can't feel it, but I can feel it for you and tell you. So I'm going to put my hand on here, and I can tell you it feels warm. But you guys can see what you feel, or what you see and what you hear. Alrighty, so you are going to make some observations about this phenomena. Pretty neat stuff. Let's look at what it looks like after about an hour. And you maybe can't see it, but there are little black, shake it, little black flecks in there. Not really warm anymore. And here's one that I did earlier this morning. So this is after about 3 hours. And this is, you can see the color has changed here. No bubbles. And here's one that I did last night. There is nothing left. Nothing at all. So we're looking for indicators of chemical change here. In part 2, later on, we'll also talk about single displacement reactions and will they actually happen. So for the future, let me go ahead and say that when a metal is trying to replace something else in a compound, in this case the zinc is trying to replace the hydrogen, if you look through this list, activity series for metals, since it's a metal that's trying to do the replacing, find the metal and then find what it's trying to replace on this list. So remember, a cation can take the place of a cation and bond with an anion. So let's look at our single displacement reaction here. So the zinc is all by itself, and so that's the metal that's trying to do the replacing. It wants to replace something in this compound. And if this is a metal, that means it will try to be a cation, and it's going to try to replace the cation. I know hydrogen's a cation because it's written first. So the zinc is going to try to replace the hydrogen. And I'm going to look through this activity series and see if that's possible. Zinc has to be higher on the activity series in order to replace it. And sure enough, it is. Here's the zinc. And then down here lower is the hydrogen. So zinc will be able to replace the hydrogen. Zinc is going to take the place of the hydrogen. And it's going to kick the hydrogen out, and the hydrogen will be all by itself. So let me write H here. I need to remember that hydrogen is diatomic, and so anytime it's alone, you have to say, well, it's going to bond with itself. So it'll be H2 there because hydrogen's diatomic. So what about the zinc? What happens to that? Well, it takes the place of the hydrogen and forms a compound with the chlorine. So the zinc and the chlorine are going to chemically bond with each other, and that's how this is a chemical reaction. So what compound do they make? Well, we need to figure out what ratio they bond in. So the charge for zinc is always a 2+, and the charge for chlorine is a 1-. And if I do the crisscross, I can see that I'm going to need a ratio of 1 zinc to 2 chlorines. So the chemical formula for that would be ZnCl2. ZnCl2. Now, is this equation balanced? Well, we always need to go and check. And I can see that on the right-hand side, I've got 2 hydrogens and 2 chlorines. And here on the left-hand side, I've only got 1 hydrogen and 1 chlorine. So I'm going to need to put a 2. It has to obey the law of conservation of mass, right, to balance. So I have to put a 2 there to make 2 hydrogens and 2 chlorines. So that is the single displacement reaction between zinc and hydrochloric acid. Thanks for joining me.